let's start with the topic light. This is third most important topic as related to your board syllabus. Okay. Today we shall be starting with a few basic concepts that we have already taken in our 8th standard, such as what are the sources of light, what are the medium of light. After that we will be switching on to behavior of light, on surface boundary, along with it we shall be taking the definition and laws of reflection, our main topic. Alright, let's take the topics one by one. Sources of light. As we already know that light is a form of invisible energy that gives us sensation of vision. Alright, having said that, what are the few sources through which light is coming out? That is very important. So our sources of light are those objects or substances through which light comes out. That is, but whenever the light is coming out, that light could be of their own or they could reflect the light falling on them, such as moon, take example. So they either emit light of their own or they reflect the light falling on them. Based on whether they are emitting the light of their own or whether they are reflecting the light falling on them, they have been classified into two categories. One are called luminous sources. Second category is non-luminous sources. Luminous sources could be living or non-living. In non-living or artificial luminous sources, for example, bulb, for example, sun, for example, your tube light, stars, etc. Coming to our living luminous sources, these sources are also called bioluminescent organisms, such as firefly. Or you might have observed some kind of mushrooms which emit light on their own. For example, jack-o'-lantern mushroom, there are also some breeds of fishes such as jellyfish which emit light on their own. For example, crystal jellyfish. These are our luminous sources which emit light on their own. Now, talking about the non-luminous sources which reflect the light falling on them, a few of them are like moon, board, humans, animals, plants, etc. Non-luminous sources which are reflecting the light that is falling on them and we are able to see them. Alright. After sources of light, let's switch on to our medium of light. Remember, we have already studied these topics in our 8th standard. We are just Taking a quick recapitulation. Medium of light, just as we have already studied, are the sources or the medium through which light travels. So, they allow the light to travel through them. But question is, on what amount? Based on the amount of light that they allow to travel through them, they have been classified into three categories. First, transparent medium. Second, translucent medium. And third, our opaque medium. Alright, transparent medium. These are the media through which light travels fully, or they allow the whole amount of light to pass through them. So, our example of transparent medium could be air, glass, water, that is still water, water which is at rest. Likewise, we could get many examples. Translucent medium, medium which allow the light to pass through them only partially. So, example of translucent medium could be butter paper, or our glass windows of cars, which are nothing but colored glass windows. So, colored glass, muddy water, likewise. Now, coming to our third medium called as opaque medium, they do not allow any light to pass through them. Example of opaque medium could be such as this board or a mirror or chair, table, etc. These are our medium of light. Now, our transparent medium, depending on the optical density of this medium, that is, whether the medium is allowing the light to pass through it with full speed, or whether the medium is giving any hindrance in the speed, it is lowering down the speed of our light. Transparent medium is further classified as optically rarer and optically denser medium. Why we are using the word optically? Because through transparent medium almost all the amount of light passes. In optically rarer medium, these two medium are always on the comparison term. In optically rarer medium, our speed of light will be more, and in optically denser medium, our speed of light will be less as compared to this medium. Take for example air and glass. Whenever light travels through air, its speed will always be greater than when it travels in the glass. So for a pair of medium air and glass, velocity or speed of light in air will be higher and speed of light in the glass will be lower. Alright. Now let's see how our light ray would behave on any surface boundary. Before seeing this behavior, let us discuss what a surface boundary means. Surface boundary, in this sense, any boundary line that separates two medium. Suppose here it is medium 1, here it is medium 2. Take for example this plane of this board. The plane of this board, that is this upper surface of the board, acts as a boundary because it is separating the air on this side and the board surface on the other side. So this surface of the board acts as a surface boundary which is separating two media. One is air and another one is board. Likewise, let's suppose this is our surface boundary, also called as interface. Alright, whenever a light ray falls on this surface boundary, suppose this is our light ray which is falling, it will be called as incident ray. Whenever a light ray incident on a surface boundary, three phenomena happen. First one, it could just go back in the same medium. Suppose a light ray is coming from the air, striking this board and then going back again in the air. This phenomena is called as reflection. So this ray will be called as reflecting ray. Okay. Next thing happens, suppose if it weren't an opaque surface, if the board were made up of a glass, then the light ray coming from the air would transmit into the glass and go backward. Whenever incident ray strikes the boundary surface and gets transmitted into another medium, this phenomena is known as refraction and this ray is called as refracted ray. Okay, now what about the third phenomena? We have already understood that incident ray going back in the same medium will be our reflection. Incident ray transmitting into another medium will be our refraction. What about the third phenomena? That third phenomena is shown because the intensity of the incident ray gets reduced if we somehow calculate the intensities of reflecting and refracted rays and add them. So where does that extra intensity went? That extra intensity goes in another phenomena called as absorption. So whenever light rays is striking any boundary, either reflection could take place or refraction could take place or some amount of light could be absorbed by the medium. Now we shall be going into our last topic, that is reflection. Remember, reflection holds quite weightage in your board syllabus. So we shall be taking it slowly one by one. It is a simple process or a phenomena where whenever a light ray is striking any surface boundary, it gets bounced back in the same medium. So definition goes like, the phenomenon in which when a light ray bounces back in the same medium after striking any surface boundary. This is your technical definition of reflection. Now, let's see some basic terms related to reflection. Suppose AB is the boundary of any surface. The light ray that incidents on the surface or falls on the surface is called as incident ray. Let's suppose it is IO. the point on which the incident ray falls. This point is called as point of incidence. Now, at point O, if we just draw a perpendicular to our boundary surface AB, we will get NO called as normal. In physics, normal refers to anything that is perpendicular to anything. Alright. This incident ray, since it is a case of reflection, so it will bounce back in the same medium. The ray OR, which is bouncing back or getting reflected, this ray is called as reflected ray. Now, we have already talked about the rays or the lines. Now let us discuss about some angles. The angle that incident ray makes with the normal, this angle I, is called as angle of incidence. So the angle that the reflected ray will make with our normal will be called as angle R or angle of reflection. Now, there are also other angles, this and this angle. The angle that incident ray forms with our surface, this angle is called as glance angle of incidence. Now, since normal is perpendicular to this surface, that means our glance angle of incidence is equal to nothing but 90 degree minus I. Same way, the angle that reflected ray forms with our boundary surface, that angle is called as glance angle of reflection. And again, the value of that angle will be 90 degree minus R. Alright. These are the basic terms related to, these are basic terminologies related to reflection. Going forward, let us discuss a few laws on which our reflection is based upon. So, next, laws of reflection. Again, we shall be drawing the same figure. Laws of reflection. First law goes like incident ray, normal and reflected ray at the point of incidence always lie in the same plane. Remember one thing, we have focused on the word always, and that word only comes at the point of incidence. Otherwise, it is not necessary to be in all the cases. So, our first law is the incident ray reflected ray and normal, where at the point of incidence always lie in the same plane. Our second law of reflection is that angle of incidence is always equal to the angle of reflection. This one is very important law which helps us in doing various questions. Now, if incident ray is equal to the angle of reflection, so just look over here. Another corollary that we get from that law is that our glance angle of incidence and glance angle of reflection will also be same, because here if we just do the derivation, I equals to R, so minus I equals to minus R, and so 90 degree, if we just add 90 degree on both the sides, so 90 degree minus I equals to 90 degree minus R, that is our glance angle of incidence is equal to glance angle of reflection. This is also a corollary based on our second law. Now, let us talk about normal incidence. Now, what does a normal incidence mean? Normal incidence means when our incident ray falls perpendicular to our boundary surface. Let us see that case. Our incident ray is falling perpendicular on our boundary surface. If it is falling perpendicular on the boundary surface, so at point O, the normal that will be making, that will coincide with our incident ray. When normal coincides with our incident ray, that means angle of incidence in this case will be 0 degree, which is the angle between incident ray and the normal. From second law, angle I equals to angle R. So angle R be again equal to 0 degree. That means the ray will always retrace its path. This is also called as reversibility of any light ray. So for normal incidence, angle I equals to angle R equals to 0 degree, and so the ray retraces its path. Alright, now let us discuss reflection through some surfaces, whether regular surface or irregular surface, whether plane surface or a spherical surface. Let us switch on to that. Our regular surface is any surface which is highly smooth and polished. So our regular surface would look like this. Well, in most of the cases, our reflection takes place through opaque medium. This is the case for our regular surface. Talking about irregular surface. Irregular surface is any surface in a zigzag way or having roughness. So that surface would look like somewhat this. This is our irregular surface. Now, let us take three incident rays parallel to each other, falling on the surfaces. Here also let us take three incident rays parallel to each other. At the point of incidences, let us draw normal. Normal on any curved surface, that normal we have already seen in property of any circle, that at any point normal would be perpendicular to the tangent, right? So on this surface our normal would be perpendicular to this. On this surface normal would be perpendicular to this, and on this surface normal shall be perpendicular to this. Let us draw the normals. On this surface our normal would go like this. On this surface our normal would go like this, and on this surface our normal would go like this. Alright. You might have observed that in these two cases, for the regular surface, normal are parallel to each other. But in irregular surface, normal are not parallel to each other. from our second law of reflection, angle of incidence is equal to angle of reflection. So all the rays that have come parallel have again gone back parallelly, right? Here again we are following our second law of reflection, angle I equals to angle R, but the observation over here is that angle of incidences in all the three cases at all the 3 points are different. So we will get different angle of reflections, and accordingly we will have this kind of ray. Here we will get regular reflection, that is maximum amount of reflection takes place. Here this is called as diffused reflection. Why diffused? Because some rays are going in this direction, some are going in this direction, some are going in this direction. So if we are standing over here, we will be viewing only 2 rays, not the third one. If we are standing over here, we will be having all the 3 rays in our eyes, and so we have maximum reflection in case of regular, and diffuse reflection or partial reflection in case of our irregular surface. Alright, now for our regular surfaces, henceforth we shall be taking the cases for maximum reflection. So we shall be taking regular surfaces. A highly polished smooth surface or a highly polished smooth regular surface is also called as mirror. So now we shall be taking the cases of reflection in case of mirrors.